So the other day we covered section 6.1, which talked about areas and things like that underneath the standard normal curve. We're going to expand on that in section 6.2 and work with areas for non-standard normal curves. Now, non-standard normal curve simply means that the mean and standard deviation are no longer 1. So if you have a standard normal curve, we usually use Z to denote that. And this is a little symbol called tilde. It means Z is distributed normally with a mean of 0 and a standard deviation of 1. Now in our first problem here, it's going to talk about IQ. So IQ, according to this problem anyways, is distributed normally with a mean of 100 and a standard deviation of 15. Anything other than a normal 0, 1, we'll just put an X. Is distributed normally with a mean of 100 and a standard deviation of 15. This is my notation. It's just convenient. It wraps everything up in one small, tight, neat package. Now to find these probabilities, you're going to have to look things up in either Google Sheets or StatDisk or a table or something like that. But in our class, we're going to focus on Google Sheets. There's two commands that we're going to use in this section. The first one is norm distribution. And norm distribution gives you the area to the left of some particular number. So in this case, we would type in, since we want the area to the left of 95, should be norm dist of 95, and then the mean, which is 100, the standard deviation, which is 15. Does anyone remember what follows that?
True.
True. Always going to use true after that. So let's look that up. In fact, I think that one's done for us already. If you type that in, you should get about 0.3694 for that probability. So let's pop that in, 0.3694. Working good there. So far, so good with example A. Let's continue with the second part of example A. This one's a little bit different because they ask you to find the area to the right of 80, is that 88 or 86? 88, yep, 88. So, but keep in mind, even though you might type in an 88 and want the area to the right of 88, Google Sheets is still going to give you this area here in yellow, the area to the left of 88. So how am I eventually going to get the area to the right of 88? What am I going to do? Exactly. Perfect. So thank you, Chloe. You're going to take 1 minus that. So you're going to subtract off that little piece and you'll be left with that piece. So you can do that in one command or in two. Now originally when I started this problem the other day, I did it in two separate commands. That is, I found the area to the right, or to the left of 88, and then I subtracted 1 from that, so I did it like this. Here's the area to the left of 88, and then in the cell below that, I said, oh, well, I just want 1 minus the cell above. So however you want to work it is up to you. On the left-hand side, or left part of this, I get the area is 0.2119, and then essentially its complement is going to be 0.7881. If you wanted to, you could do this command all in one go. You don't have to do it in two separate cells. You could just write equals 1 minus norm dist of 88, comma 100, comma 15, comma true. And that would give you that area right there. So, all right. 2 down, and I'll do one more of example A by way of review. This time I need to find the area between 2 points on the normal distribution. So, okay. Got to think a little bit more on this one than we did the other ones. So I want to try and find that area. How am I going to find this one? What am I going to type in for that? If I type in 110, for instance, along with the rest of this stuff, I'll get the area to the left of 110. But I want the area to the left of 110 extending to, say, 85. So
I'm fine. We plug it in like separately, and then we minus what we get out of those two.
Yeah.
We minus those two.
exactly. So you're going to find both areas. Once you find the area to the left of 110, you're going to subtract off the area to the left of 85. The difference is going to leave you with the area between 85 and 110. So let me type in the commands or show you the commands for both of those, and then you got to subtract them. So equals norm distribution. So the first one is going to be 110, and then 100, and then 15, and then true, minus that same stuff, norm distribution of 85, 100, 15, and true. Nice. So the difference then is just going to be the area in the middle. I think I set that up with a total of 3 calculations. So the first one is just the area to the left of 110. So here's your command there. Let me see if I can't make that a little bit bigger here for us to see. The second one is the area to the left of 85. And the third one is the difference in those two cells. You could, if you wanted to, just find the difference right away. Do this all in one line, but you know, it's kind of nice to be able to see all the different parts of this. The final answer here should be 0.5889, rounding that to the nearest 10,000th has been our conventions. If on the exam I want to ask you for a specific decimal place, then I'll tell you. I'll say I'll round it to the nearest 100th or 1,000th or 10,000th, whatever it may be. So those are a couple review problems from the other day. Let's keep going. There's 2 commands that you're going to use in working your way through section 6.2. One of them was norm distribution. That's when you've got an x value and you want to find an area. If you've got an area and you want to find the x value or z value, then you're going to use a different command, and that's going to be norm inverse. So let's see. Norm inverse starts out with an area and gives you your x value or your z value, depending if you're working with the standard normal distribution or not. So let's practice that with this one. Now, let's just focus in on this part of it. I think I accidentally copied part of this by mistake, but I am going to make use of that initial part, or that initial part. But right now, let's just find the z-score that corresponds to the shaded area. Round to the nearest whole number is needed. All right, well, that's a little weird because usually for z-scores, traditionally you're going to round to the nearest 100th. All right, well, we're going to start out with this part of it right here. Like I said, I think the other part was an accident, but I am going to make use of that in a very constructive way. So let's see. Find the z-score that corresponds to an area in the right tail of 0.1587. Well, it's not exactly the way Google Sheets rolls. We are going to use this command down here, norm inverse. The nice thing from your point of view about the norm inverse command is that you don't have to worry about that true or false stuff. That's just not part of this command. You're going to type in x and then the mean and then the standard deviation. Let me find out who's been paying attention here so far this afternoon. What's the mean and standard deviation of a z random variable?
Z, 0, 1.
Excellent. Z is distributed normally with a mean of 0 and a standard deviation of 1. Beautiful. So if I want to find that area, I'm going to look it up with this, except there's one problem. this command works with the area in the left tail. And I wasn't given that. I was just given that I have 0.1587 of the area in the right tail. So how much is in the left tail?
Minus this and one?
Yeah, you're gonna have to do 1 minus this. So 1 minus 0.1587 sounds to me like 0.8413. So that's how much area is here. And that's what you're going to put in your command for Google Sheets, is it's going to be norm inverse of the area as a decimal, 0.8413, then the mean, then the standard deviation.
But isn't the mean and standard deviation 150 in this problem?
We're going to go back to that part in a second. As I said, we're just going to focus in on this part, the second part, initially. I think I copied this into the notes by mistake. I am going to expand the problem and go back here. But for the initial problem, we're just doing the part that's in yellow. And that area should be close to 1 if I remember right. So let's take a look here. So example B, it's going to equal norm inverse 0.8413, comma 0, comma 1. Yeah, 0.9998.
I got a question.
Yes.
Just to make sure, so you would only put true if you're trying to find on the left line, right?
So true is just not a part of this command
Right.
at all. So you don't have to worry about true unless you're working with the.
Left side.
No, you're only using true if you're trying to find an area and you start out with a z value. So if you look back at the first one that we did, we started out with these values here, and these are x's because it's not a normal 0-1 distribution. But if you start with the values here and you're trying to find the area, then you're going to use the Normdist command, and true is part of that command. But for the norm inverse command, you don't have to worry about true or false at all.
Okay.
So just a quick FYI, true means you want the total area to the left of that point. If you're dealing with false, false says you really want the height of the function that creates that curve. Now, you can close your eyes if you're faint of heart for a moment, but here's the function that creates that curve. It's 1 over the square root of 2 times pi times the standard deviation times e to this messy power. If you wanted to find the area underneath that curve, excuse me, the height of that curve, you would use false there. The short answer is you're never going to use true, or never going to use false as part of this command. You're always going to be true because we're always looking for the area. We're not looking for the height of that value. So just keep it simple for yourself. In fact, I was thinking about modifying my handouts to just put true there and not put, condition. Because in this class, you'll never use that. If I round this to the nearest 100th, then it means looking to the right, and then I have to add 1 here and add 1 here. And, well, what do I end up with? Should end up with 1.00 for my z value. So, okay, great. And that's the part in yellow right here. That's all I did. But chances are you might be asked to go a little bit farther than that. And let me show you how to do things kind of old school first. So a lot of times you might be asked to find a certain percentile. And in fact, we can give this a percentile. We can call that P sub 0.84 or 0.8413 if you want to be really precise. Let's keep in mind what that represents. That's the point that represents the lower or that separates the lower 84.13% from the upper 15.87%. So that's all it is. But what would that percentile be for this distribution? Let me highlight that in pink. So if we have IQ scores, which are normally distributed with a mean of 100 and a standard deviation of 15, what's the 84.13 percentile of that distribution? Okay, well, that's a good question. It used to be we'd have to do it like this. And this was kind of a lot of work for our students. You'd have to take the mean plus sigma times the standard deviation times that z sub alpha. Remember, z sub alpha is the point with that much in the tail. So this would be z sub 0.1587. Notice it's kind of like the complement of our percentile, because it's talking about the area in the right tail. That value was essentially 1. If I wanted to figure out the 84.13 percentile, then I would take and calculate this. X equals mu plus sigma times z sub alpha is going to be 100 plus 15 times z sub alpha was, for all practical purposes, it was about 1. So that tells me the 84th percentile here is about 115. Okay, that's great. Now, in addition to the pain of having to find and do this calculation, students used to have to find this value by looking up a z-table. Let me show you how easy this has gotten for this class. Here, I'm just going to change, instead of 0, 1, how about if I put in 115? That's going to be what I'll need for this calculation. So let's do it down here, equals norm inverse of 0.8413, comma 100, comma 15, and I'll get something very close to this. The only reason I won't get an exact number is because I rounded this answer up here, so it'll be a little bit less than 115, but not by much. So let's see, equals norm inverse of 0.8413, comma 100, comma 15. There you go. Like I said, this calculation has gotten a lot easier for this class. Philo, question? No? Okay. All right, so 114.97, etc. So basically in this section, and in section 6.1, you're going to be using one of two commands. You're going to either use norm inverse or norm distribution. And let's try and be clear about what command you're going to use when. So let me do that. Let's see. Let's see. Let me do that at the top. So it kind of depends what you're starting with. If you start with the area and you want to find the value, start with the area. You need to find the value. Use, anyone? Which command?
Inverse.
Norm inverse. If you start with the value and then you want to find the area, then we're going to flip things around. So start with the value, then find the area, use which command? Norm distribution. Now on your exam, on the very top, I will give you all these different commands that you could need off of Google Sheets. This course is not learning about learning Google Sheets. It's just a very, very convenient way to do this stuff though. So what you'll see at the top of your exam is this. This is all the summary of all the Google commands that I think you could use. I mean, do I need to put down mean and standard deviation? You got that one? You type in average and then type in STDEV. Those give you the mean and standard deviation. But this is not a course about memorizing commands for Google Sheets, so I will give you those. You just have to know which ones to use where. All right, let's continue. Let's go down to example C here. And I think I've got this open. Let's see, maybe not. Okay, I'm gonna have to open it up from our link here. There. So this is a frequency histogram for the relative, or for the average monthly temperature in the month of February in Oakland County for the last 128 years, going all the way back to 1895. So if you look at it and kind of wink and nod a little bit, it looks like a normal distribution. Is it perfect? No. But later on in this course, we'll learn ways that we can try and decide if something actually fits a normal distribution or not. So in this particular case, maybe I want to figure out, well, you know, what's the 99th percentile for this normal distribution? That is, what point is going to be the cutoff between the top 1% and the bottom 99%? So which command does it sound like I'm going to use? Norm distribution or norm inverse? Am I starting with an area and trying to find a value, or starting with a value and trying to find the area? Well, if you're looking for the 99th percentile of that distribution, then let me see if I can't draw it here real quick. And you're looking for that point way out here in the right tail that separates the bottom 99% from the top 1%. So that point there. Let's get straight on a couple different notations for that point, or the name of that point. Well, I guess it depends on what you're trying to find. But right now, I've got the point that's got 1% of the area in the right tail, so that would be P99. But that's not how Google works when it's working with the normal distribution. It always gives you the area in the left tail. So what is that area in the left tail going to be? Yeah, this is going to be your 0.99. So if I want 0.99, if I'm looking for this value down here, what's that value down here going to be?
0.0.
Well, that's going to be here. How should I find it, I should say? Norm distribution or norm inverse?
Distribution.
Well, let's look back.
Oh wait, because you have the 99% inside.
Yeah, the 99%, that's your area.
Yeah.
So if you're starting out with 99%, you want to find the value, then you use norm inverse. So norm inverse. Let's think about what else we need here. We're going to put in the area in the left tail, which is 0.99. And let's look back at our little Desmos thing here. The mean is about 27.3 and the standard deviation is about 5. That's for the data that's mostly hidden behind this. You can see more of it that way. but I'm not going to show you all 128 items. So we're just going to go with a mean of 22.73 and a standard deviation of 5. Mean of 22.73, standard deviation of 5. On the exam, I will have to do one of two things. Either I'll provide you with the data set, in which case you can calculate the mean and standard deviation, or I'll just give you the mean and standard deviation and let you work at it. But one way or another, you don't have to make up the mean and standard deviation. You'll be able to figure it out, or it'll be given to you. Most likely it'll be given to you. I don't want you to make mistakes figuring it out. And then those propagate into errors in the rest of the calculation. All right, so let's see, this is example C. Equals norm inverse. What kind of values are you getting? All right, sounds good. About 34 some degrees, 34.36 degrees. So 34.36. Nice. Nice. Now here's a nice follow-up question asking you to kind of think a little bit and to go back into your memory. Before I do that one, are we okay with this first one?
Could you go back?
Yeah, go back where?
Go back to the decimals thing.
Oh, so the decimals thing, where is it? It's right here. It's just, the thing that you should get off the decimals thing is that this is about a normal distribution, and the mean was about 22.73, and the standard deviation, I rounded it off to 5.
Right, so you said like you're gonna give that.
Yeah, so either I gotta give you the data set, in which case you can calculate the mean and standard deviation, or I'll just give you the numbers. Yeah. So, but the problem is really for you to figure out that you need to use norm inverse and that you gotta type in 0.99 here, because if you type in 0.01, it's gonna give you that little piece over here, which is gonna be wrong. Yes?
So, because we're given 99%, just think of it as our like probability density, where that's our area that we're given.
So 90, what this is saying in kind of practical terms is that 99% of the time, the average monthly temperature in Oakland County for February is going to be less than or equal to 34.36. That's what it's saying. 1% of the time, you're going to be above that. I guess the reason I chose the 99th percentile is because I feel like it's been unusually warm so far this month. And yeah, especially today. And of course, in the winter months, if you get a really warm day, it's often accompanied by really strong winds. So yeah, that's why I went with the 1% there.
Should your answer just be equals 34.6, or should you write out 99% of the time?
No, you don't have to write out the rest of that. I mean, really what I'm looking for is this right here. Yeah. All right, so the next part of this is to figure out what the third quartile of this distribution is. So you're gonna have to go back and think about third quartile. What is the third quartile? What am I asking you there?
What's the 1%?
Well, quartiles divide your data into how many parts? 4 of them. And there's 3 quartiles. But what's the third quartile? What's the first quartile? I mean, it's like, yeah, that makes a difference. The second quartile is also known as the median, all right? That's the 50th percentile, the second quartile. But what's the third quartile? What chunks does that separate? The top what from the bottom what?
Bottoms.
Grace?
Top 75% or
Bottom
The bottom
75 from the top 25.
Bottom 75 from the top 25? You agree with that? All right, thank you, ladies. Yeah, it separates the bottom 75% from the top 25%. So type in a Google command and get that. We'll have to circle back at the end of February and see how we did. See how unusual this month is. Not for myself, a lot of times I get a little bit lazy with Google Sheets. But what are you getting? What value did you get? Didn't work?
Like 26.
All right, 26. Now keep in mind, the third quartile separates the bottom 75% from the upper 25%. So I don't exactly have room to draw it here, but let me draw it here. So the third quartile is going to be somewhere here. It's going to separate the bottom 75% from the top 25%. So I know that my variable is distributed normally with a mean of 22.73 and a standard deviation of 5. So if I want to find this point, which is Q3 or P.75, the 75th percentile, that's going to be norm inverse of 0.75 and then the mean 22.73, comma 5. I think that should give you around 26. Let me just double check here though. So from my point of view, some people might call it laziness. I call it economy of movement. I'll just copy that one down there and then change that to a 0.75. So there you go. About 26.1. Are you able to get that as you do the calculation? Looking good on that one? Ben? Thumbs up? All right. Thank you. So 26.1. Let's keep going, unless there's some questions on example C here. We doing okay with that one?
Can I see that other sheet of notes you put up for a second? I mean,
This one?
the one where you drew X.
Oh, where I drew it? Yeah,
Right there.
right there. Sure. Anything else on this one? A little fuzzy. Chloe, you don't look like you're terribly comfortable with this one.
Yeah, I might, can we do some practice at the end of class with it?
Yeah. So two things. We're going to do some practice now. We're going to keep on practicing these same things. There's absolutely nothing new beyond what we've already done. And then after I finish this section, you'll have time to practice for the exam. So, yes, you absolutely can get some more
We're gonna
practice.
get a review sheet or something like that?
There is a review sheet on D2L already. All right, so according to Google, this is different than what it shows in your authors, or what shows in the actual textbook itself. According to Google, the heights of men are normally distributed with a mean of 70 and a standard deviation of 3 inches. So for men, it would look like this. X is distributed normally with a mean of 70 and a standard deviation of 3. For women, X is distributed normally with a mean of 64.5 and a standard deviation of 2.5. What I want you to do is I want you to find your percentile of height. So one thing you're gonna have to do is you're gonna have to convert your height to inches, because this is all done in inches. So take the number of feet times 12 plus the inches. So for me, it'd be 6 times 12 plus a half. So it'd be 72.5. For you, whatever it is, I'm not gonna ask you for this number. This is just yours. But try and find basically what percentile of height you're at. Now, let me ask you this. In finding your percentile, are you going to be starting out with, are you going to use norm dist or norm inverse? Which one? Which one do you think?
Inverse and this.
Inverse, dist. Which one?
Inverse.
Are you starting out with the value and trying to find the percentage, or starting out with percentage and trying to find the value? Which one are you starting out with? Which one are you ending up with? Let me see what the decision is on the chat. Couple votes for norm inverse, but realistically, you're starting out with your value and trying to find the area, because it's your area that's the percentile. Because the area that you find is going to be the area in the left tail. So give that a shot, see if you can't figure out what percentile of height you're in. So for me, it would look like this. Equal norm distribution of 72.5, comma 70, comma 3, comma true. And I think that's around the 80th percentile. I have to double check. But let me walk around and see what you got, what you have. And if you have some problems, let me know. If you're watching this later, fast forward until I remove the pause. I'm surprised it doesn't like suggest it for you.
It actually, it does, a bunch
Oh,
of these
okay.
show up in this thing. when it
Oh,
does.
okay. All right, that's cool.
Yeah.
I mean, it's not a bad idea to use those, because sometimes you can accidentally mistype something and it'll give you the wrong
Yeah.
command. So that might be a better way to assure yourself that you got the right command.
Yeah, cause then it sets up the parentheses for me too, and I can just.
Yeah, yeah, I find it very convenient that it does that. Did you get it? Oh, you're right on. That's pretty easy. You don't even need to look it up. It's like right there. So, cool. Should be a little bit above the 50%. Yes. Yeah. Beautiful. Yeah. So, oh, actually, no, you're gonna use this because that's your height, right? So, oh, yeah, that should mean that you're standing. Yeah. So those and then comma true. Okay.
Yeah, I know.
All right, cool. So if you're 5 foot something, so that's 12 times 5 is 60 plus whatever inches. So that'd be what you put in. All right, one. You're 6 feet tall. Really? That's impressive. Wow. Nice. Feeling okay?
Yeah.
Feel? Ya, sí. ¿Cómo estás? ¿Eso qué estás? Sí, eso es bueno.
I would have wrote it. I would have wrote it on the.
Alright,
Right, it was 100% as well.
let's see. So, yeah, 92nd percentile.
So is it like the shape here?
Yeah, 92% to the left.
I think they're
And then 1% to the right, so there's only 8% of people that fall.
So
Bigger than that.
so
Yeah, that- It'd be P sub 0.92. Yeah. Good.
I don't know.
Oh, yeah, okay. Alright. Okay. Alright, good. Good? Alright. Okay, so let's take a look here. For myself, like I said, just over 6 feet. And that'd be, say, example D equals norm distribution of 72.5, comma, 70, comma, 3, comma, true. So about the 80th percentile. Now, if you're curious, I mean, well, what does that mean? How would I draw it? Let's take a look at that. So, let's see, what was the exact number? 0.79, where is it? Here. 0.798, we'll call it 0.7977. 7977. So if you wanted to draw that, really what's going on here is that that's the 80th percentile, so about 20% of the area underneath this curve is going to be to the right. So out here is about 20%, and then to the left is the rest of it, so that's closer to 80%. So that's what we just found is that area is 0.7977. 0.7977. So you could call that P sub point, I don't know, I hate being so exact here, 7977, but it's about P sub 80. P sub 0.080. So 80th percentile for that one. Okay, and you know, I saw walking around, I saw a variety of values. We have somebody that's in the 99th percentile. Wow, good on you. That's impressive. So, all right, we're good with example D here. We're gonna do 2 more problems by way of practice. Let's flip it over onto the back side here. This is some more destandardization. And, you know, I thought I had changed this, but it got changed back somehow, I guess. Engineers want to design commercial aircraft so that they are wide enough to fit 99% of all males. Accommodating 100% of males would require seats that are very wide, that would be too expensive. Men have hip breadths that are normally distributed with a mean of 14.6 and a standard deviation of 0.9. So right here is some relevant information. Let's just write that down like this. X is distributed normally with a mean of 14.6 and a standard deviation of 0.9. So just to kind of have that handy. We want to find P99, the 99th percentile. So, okay, let's see if we can do that. So here's my distribution. That's X is distributed normally with mean of 14.6 and a standard deviation of 0.9. What should I label this with down here? 14.6. Yeah, that's your mean. That's what divides things down the center. Let's think. What else? We want the 99th percentile. Is that going to be to the right of 14.6 or to the left of 14.6? Where do you think it's going to be? Yeah, it should be to the right. So it's going to be out here, somewhere out in the tail. Is going to be the point that separates the bottom 99% from the top 1%. So 1% here, 99% here. The good news is that when you're using Google Sheets to find a percentile, you're just going to work with that percentile. You don't have to do a -1 thing. So if I want to find a 99th percentile, am I going to use norm distribution or norm inverse? Norm inverse, good. So this is going to be norm inverse of 0.99. The mean is 14.6 and the standard deviation is 0.9. And that's it. You don't have to worry about a true or false in this one. It's just norm inverse of that. And let's see what you get. Example, well, I get it up here. Example E equals norm inverse. Abby, what'd you get?
Me?
Yeah. All right, so I said Abby, it's Gabby, my bad. No wonder why you give me such a vacuous look. You're like, who, me? All right, somebody got this number? Cody?
16.69.
Perfect, 16.69, yeah, we'll round it to 4. I should round it to 2 digits. So 16.69 should be good enough. 16.69. Nice, thank you. Yeah,
Wait, can I see the formula you used? Because I have the wrong answer.
so 0.99, 14.6, and 0.9.
Oh, I forgot the point. That's why.
Okay.
Thank you.
Yeah, if you didn't have that point there, that would make a big difference. Do you think it would make a big difference if, you know, an airline said, you know, we really don't need the top 1%. It's enough to get the top 3%. What change would I have to make to this part right here?
0.97.
Yeah, 0.97. I don't think it's gonna make a big difference, but, you know, I don't know. They seem to fight us on those, that leg room, you know. I always feel like I don't get enough leg room on an airline. All right, so it makes about 0.4 inches of a difference, so not quite half an inch. Not sure if they would worry about that or not. Let's finish up with example F. And this is a two-parter. Let me look at it here. I think this will be a little easier to see. A survey found that women's heights are normally distributed with a mean of 63.8 and a standard deviation of 2.2. A branch of the military requires women's heights to be between 58 and 80 inches. Find the percentage of women meeting the height requirement. Are many women denied the opportunity to join this branch of the military because they are too short or too tall? So let me graphically describe what's going on with the first part for us. So we've got women's heights are normally distributed according to this with a mean of 63.8 and a standard deviation of 2.2. So the values Google was giving are a little bit more generous than that in terms of the standard deviation. So here's our 63.8. 63.8. Bless you. Let me just write X is distributed normally with a mean of 63.8 and a standard deviation of 2.2. That's not notation that the book uses, nor is it used on my stat lab. So we're looking at trying to find the area between women with a height of 80 inches, which is going to be way out here, and heights of 58 inches. So down here. What percentage of women have heights in this area? How are you going to find that? Yes, norm distribution and then subtract. This is just like what we did with that third part of example A. You had to find the area to the left of 110, subtract off the area to the left of 85, and that will give you the area in between. So you got to do that with this one. The second part says, if this branch of the military changes its height requirements so that all women are eligible except the shortest 1% and the tallest 2%, what are the new requirements? So here's part B. Here's kind of a visual for that. Ooh, that was a good one. All right, good on me. Usually they're not so symmetric. All right, so same distribution. X is distributed normally with a mean of 63.8 and a standard deviation of 2.2. 63.8. Except this time, I've got to cut things off so that I'm excluding the bottom 1% and the top, top 2%, yeah, top 2%. So basically I want this area to here to be 2% and this area here to be 1%. I gotta find these values. And I'm sorry I wasn't zoomed out enough. I need the top 2% here and the bottom 1% there. So fire away. See if you can't find those. And as usual, if you're watching this later, skip past the pause button.
Now we could approach it a different way, so.
At the area, and you're trying to find the x value. So what command would you use for that? Yeah, Norman versus you want to use Norman versus 1% on the left tail. Here, how much is in the left tail? 2% is in the right tail. How much is in the left tail? 2% is in the right tail. How much is in the left tail?
Sorry.
Oh, that's all right.
Oh, I'm sorry. Yeah, so the first one is so far away from the right tail, essentially. It's shorter than that, so, yeah. Except for this one, is 1.2, that's gonna be the bottom 2%. That one's correct. Or you have to change for the other one. Let's do that. Yeah, so basically what's going on is that there's no room for taller than 8 inches. It's just not something to see. So, that's going to subtract off the area here. It's going to go up by the some numbers. Yeah, so this one you got to use Yes, definitely shaded one. Yes. Yeah, that's a great, in fact, I'm gonna use it as a teaching tool. Good job. Let's see. Yeah, yeah, using Normdist and NormInv. Where you just gotta figure out which one is, which number you wanna put in.
It's a bit lost in
Here we're finding the x, given the area, that's your norm inverse. Here you did the other way. You had the x in the area, distribution, so that's what you should use here. Here you don't use
the
yeah, I think it would. Hold on,
It's
Oh, no, no, what's happening there is that that's such an extreme height, that essentially everything destroyed everything. And there's very few people here, so the difference is like all these.
Yeah.
Okay, so yeah, that's right.
That's what we do.
Yeah, so it's 98% there that you have to take. And that's what you did. So that's good. Come check in over here.
Is this right?
I think it might have miscopied a decimal or something like that. It should be like 0.00471 or something like that, I'm not sure. But it should be really, really small.
Oh,
So you might want to double check that decimal. I think, yeah, you
I
just,
might have typed it wrong.
yeah, no, you copied the wrong decimal, I think.
And then
Yeah.
this one, it would be.
Yep,
0.98,
that one's that.
And then 0.01.
It's definitely something I'm saying something.
Okay. Which part?
Command would I be using? Because I started with norm inverse.
Which part are you doing? Part A or part B? Part B. Yeah, norm inverse is what you're doing, because you're starting out with the area, you want the x value.
Yeah.
So norm inverse, and then you gotta figure out, well, what area is gonna be in the
It'll be 98.
98 for one of them, and then 1% for the other. Yeah, so 0.01. Yeah.
Like all one, so yeah, so I have 98, that one, that's how I get rid of the cumulative, but.
No, there's no cumulative.
Well, yeah,
for that.
cause I tried norm-dist when I
Yeah.
was doing it wrong, but so 68.31, is that?
Yeah.
That's right? Oh,
That sounds,
Okay.
sounds.
What is that
Wait,
value?
no, wait.
That's why I was confused, that seems wrong.
Oh, 60, yeah, that's 68. I thought it was 63. No, that's 68. Yeah, that's pretty tall.
Okay,
Woman.
yeah.
68 inches. Yeah.
Alright,
That's
Thank you.
that's 5'8".
alright, now I got it.
Yeah.
Yeah, I didn't.
So I got the first part, but are these the right
Yeah.
68 for one. I'm not sure for the other 58. Can.
Yeah, I got it.
Okay, so let's take a look here. Here you're starting out with the x values and you want to find the areas. So what command is that? All right, so it's going to be Normdist. So it's going to be Normdist. Yeah, I don't know why I put another I there. Normdist. Do I have my Photoshop with me? I do. All right. There we go. That was lovely. Normdist of 58. No, let's just do 80. and then 63.8, comma 2.2, comma true, minus the area to the left of that, which is going to be your norm dist 58, comma 63.8, comma 2.2, comma true. Now here's the thing. The area to the left of 80 is so far out there in terms of a height for females that it's just going to be everybody. Everybody's going to have a height less than 80 inches. So when I do that, equals norm dist 80, comma 63.8, comma 2.2, comma true. It's going to give me essentially a 1 because it doesn't even round to anything less than 1. It just says, all right, Google's going to throw up their hand and say, all right, that's a 1. So it's virtually everybody. Now, I'm just going to copy this down here and edit this command. Save myself a little time. This time we're going to type in 58. And then I want the difference of those, which is going to be pretty much like everybody. Are you excluding a lot of people when you exclude people above 80 inches and below 58 inches? Yeah, 0.42%, so less than 0.5%. Now, most people are going to make that cutoff. All right, so good. Let's try the next part. We good with the first part on part F? All right. Let's try the next part. Here we want to find the bottom 1%. The nice thing about that is that it's the lowest percentile. So this would be P sub 0.01. So that's going to be norm inverse of 0.01. And then the mean and standard deviation, 63.8 and 2.2. And that should give me something around 58.6? All right, thank you. So let's do this. Equals norm inverse 0.01, comma, let's see, 63.8, comma, 2.2. Now what's going to change? What's going to change when I do the next one?
0.98.
Yeah, the thing to keep in mind is that it always works with what's to the left of this. So, yeah, I'll be using a 0.98. I think that was Imran, thank you. Norm inverse of 0.98, 63.8, and 2.2. So that should be considerably taller, like 68 inches or something like that. So, let's see. Copy that. Paste it here, and I'm just going to change this to 0.98. So there you go. So 68 inches. That's your cutoff for the top 2%. By the way, what percentile would I write here? This is P sub 0.01. What should I write here?
0.98.
0.98. Nice. Nice. Let me remind you again of some more notation here. Well, I guess if this was the standard normal curve, you could write z sub 0.02. Because remember that when you're working with the standard normal curve, and that doesn't really apply to this, the standard normal curve is z distributed normally of 0, 1. But in the standard normal curve, the 98th percentile, P sub 0.98, could also be regarded as z sub 0.02, because it's going to be the point with 2% of the area in the right tail. That's just the way this distribution works and the way that this notation works, is it's always the area in the right tail. So on the normal distribution, the standard normal, P sub 0.98 equals z sub 0.02. So just a little reminder for you as you head into your homework. Looking good on example F. Any comments or questions on section 6.2 as a whole. Feeling better about that a little bit? You're gonna have a chance to practice some more. Imran?
I just have a question on this, basically the right, that side.
Yes.
I understand like the 0.01, it's like 1%, but
Mhm.
then for the second one, why is it like 2% and it's 0.98?
Because
Oh,
Google's always working with the area in the left tail, so that area in the left tail is 1 minus 2%, or 1 minus 0.02 is 0.98. So that's the area in the left tail, and that's why we're putting in 0.98 in that second formula. That's a good question though, and it reminds me that I said I would go back and do a teachable moment here. Let me copy this down, and suppose that I'm just really stressed out on the test and plugging away, and I type in 0.02 there. Is there something about this that is screaming out, that's wrong?
The difference is like 0.5,
0.1.
All right, so not much of a difference, but what else? Think back to the distribution. You want the 98th percentile, separating the top 2% from the bottom 98%. What's wrong with an answer of 59.28? What's wrong with an answer? What can you look at this and say, well, wait a minute, it's clearly wrong?
because there needs to be a majority in the middle. The two.
Yeah, so
The mean is 63.8.
the mean is 63.8. How much area is to the right of 63.8? How much is to the left? 50 and 50, right? So if you're in the upper 2%, which side of this do you have to be on? You have to be on the right side or the left side? If you're in the top 2%, you have to be on the right side. So an answer of 59.28, that's far to the left. There's no way it could be in the top 2% if you're not even in the top 50%. So hopefully if you made that kind of mistake, you'd look at it and go, wait a minute, it doesn't look right. And you go back and make a fix. Now sometimes, depending on the problem, I'll actually give you a normal distribution that's drawn here. It just kind of depends on the problem. So, any other comments or questions on section 6.2? So the new height requirements, and I should probably write down the numbers here. Someone want to give those to me? What was it?
68.31.
68.31,
And 0.01 is 58.68.
58.68. So that one's 58.68. So these height requirements would restrict the bottom 1% of heights and the top 2% of heights from entering that branch of the military service. That's what it would do. It says, okay, our cutoff is gonna be these people in between. So that's what it would do.
Oh, you don't need to subtract those at all, you just need the height requirements.
Yeah, you don't need to subtract these. The problem is to find these numbers in specific, not the difference. Although I do note that the difference is about 10 inches. So, Skylar, does that help out? All right, you're welcome. Let me ask you one question. Now, we've been working with the non-standard normal curve here this afternoon. Let me ask you one question. What does the standard deviation tell you about a distribution? Yeah.
How far away the data is from the mean?
Yeah, it's how far spread out the data is from the mean. Perfect. So let me show you a normal curve, a normal distribution. And right now it's set to the standard normal distribution. But if I change the mean, if I change where it's centered at, then it's just going to shift the distribution to the right or to the left like that. Notice that the shape doesn't change, the location changes. Now, if we change the standard deviation, change the standard deviation is going to change the shape. Watch what happens when I change the standard deviation. If I make the standard deviation bigger, then I get more spread on the data, right? And when I make that bigger, look what happens. The data spreads out. If I make it smaller, then this distribution gets really, really tall. All the data or all the values are closer and closer to that mean. So standard deviation here still has the same interpretation that it did back when we first encountered it in chapter 3. That is, how spread out the data is. So it's a nice visual on that. Okay, anything else on section 6.2? All right, let's call it a day here, and then you can work on your review.